So this is how you would set up a interactable object such as a door within the game. And if you implement it as an interface, then you only need to write the interact code on the player object once, and then you can describe in each of the interactable objects how that interaction should be, whether it's opening a chest, opening a door, adding an item to your inventory, whatever. All the game needs to know is that it is dealing with the interactable object, and you can define how it should interact with the object on each individual object. Hello everybody, Chris here, and in this video I'd like to show you guys how you can interact with and open a door in Blueprint code inside of Unreal Engine 4. So if you've loaded in the starter content to one of your projects, they usually come with a door by default. So in the content browser at the bottom left, we can search in door, and we'll have a perfect example of a door that we can use for this example. So you can see that this door is being indicated by the prefix SM, which would stand for static mesh. So this isn't a blueprint we can edit yet, it's just a physical object we can place in the game. So if we want to make it interactable, it needs to be a blueprint and have some code behind it. So we're going to want to take this door and also the door frame and bring those static meshes into a blueprint as components. So for now, I'll go to the root directory of the project. I'm going to right click and we're going to go to create basic asset, a blueprint class. And so we're only going to want it to be an actor because it's not really going to be receiving direct import from a controller, but rather we're going to have the player itself interact with the object. So the import goes to the player and then the player tries to interact with any objects in front of it. So go ahead and choose actor as the parent class for the blueprint, and we will call it BP for blueprint underscore door. And we can double click to open it and edit it. So to get rid of this little white dot and allow us to rename the root here, I'm going to add a new component called a scene component to the components list. So in add components, type in scene. So if you hover it, you can see that a scene component has a transform and allows you to attach things to it, but it doesn't render anything itself. So it serves as a good root for a blueprint. So once I've added that there, I can rename it door root or something like that. And now we're going to need to bring in the static meshes. So add a new static mesh component. So under rendering static mesh here, and we will call this door. And then I will add another one and static mesh. So this can be the door frame. For now, I'm going to separate this. So I'm going to drag this to door root and attach it to make sure that the door and door frame are not parented to each other. Later we may want to do that. And now for the static mesh components, we need to assign the static mesh to them. So in the details panel, when you have a static mesh component selected, there will be a category here called static mesh. So we want to click on the drop down there and put in door, find the static mesh door, and it should pop up in the viewport, and then do the same thing for the door frame. Okay, and so the next thing we need to do is to get this door into place. We can do that using the transform gizmos. So hit W if you don't already see it in this mode for adjusting the position, and then you can drag the door kind of into its space. You can see here though that right now it's doing it in increments of 10 units, but to get it to fit right in the door we might need to decrease it there. So I'm going to click on the snap dropdown and bring it down to 5, and now if we move it into place here with this particular model, it looks like it's there correctly, and we can always adjust it later if we need to. So just going around the model, and to fly like this in the viewport, you can right click and then you hit WASD to look around, and just make sure that the door is where you want it to be. The next thing we're going to need to do is to give the door blueprint some way to be interacted with by the player. Also, most likely, you're not going to want the door to move around the level itself. So go to the door root, and if you see mobility as movable, change that to static. That'll allow baked lighting, and it will decrease the load on the renderer. So for objects that are just going to basically sit in place the whole time, and I don't mean swinging open as part of a interaction animation, then you usually want that kind of thing to be static, so things like buildings. And so now we need a collider to detect when a player actually interacts with this object. So let's add a component here and type in collision. And I think a box collision would work really good for the door. So basically we're setting up a zone where when it's detected that a player is in this zone, or the interaction zone of a player is within this zone, and the player presses the interaction key, these two would be considered to be overlapping, so the interaction would be considered within range to happen, and the door will swing open or shut depending on its current state. So let's scale up this interaction zone so that it makes a little bit more sense, because that's really close to the door. So maybe we want it to be a bit bigger here. So you can select a component and hit R to go to scale mode, and then you can drag it out in X or Y and reposition it so that it makes more sense for the door. And let's scale it a little bit in the Y direction too. So it doesn't need to be perfect, but it should kind of make sense for the shape of the object. We'll rename this component interaction area and hit compile. So we're going to want to define a interact function, basically what should happen when another character comes and interacts with this particular door. But the way I would recommend doing it is that you set it up as an interface so that the player can interact with any object that has a interactable interface, which could be a door, could be a chest, or anything else in the game world. And then in the code for the objects that inherit from the interact interface, they can define what that interaction should be. In this case, it would be opening a door. So to create an interface for this, let's go back to the content browser in the main window and do right-click, blueprints, and then blueprint interface. So I've been calling it BPI. So I'll say BPI for blueprint interface, and then Interactable. So now we can double click on this interface, and now we can define what anything that implements an interactable interface should have. And that's just going to be one function for now, which is going to be interaction. So for opening a door, it won't really matter who the interactor is, but somewhere along the line, you might actually need that input. So if you want, you can add an input in the bottom right hand section here for that interaction method. So input a new parameter. So for this input, we would want to have the actor that triggered the interaction, so the interactor, and we could just make this a actor object type, which makes it very left up in the air initially. And you could always check to see if it is a player in your game by casting the actor object to the player game type. But for now, we can just make it an object reference and call it interactor. So the idea now is that whenever you call this method, you should tell it what object tried to interact with the interactable object, and then just feed that in as a variable that any interaction function call can use to do what it needs to. Okay, so for now, let's just compile that interface. I think that's all we need here. Let's go back to blueprint door, and let's make it a interactable object. So to do that, you click on class settings, and over here, there's a section called interfaces. So we want to implement an interface. So let's hit add and then search for interactable. Or you could search BPI, which was my naming convention for a blueprint interface, and add that in there. So now you need to compile the script. And in the bottom left-hand section, there should be a section here called interfaces. So you can open that up. And then there'll be a function interaction that isn't implemented yet. So we want to implement this for any interactable object. So we right click on it and we hit implement function. And now here is going to be where we write our code. So what we want to have happen is that if the door is open, we close it. And if the door is closed, we open it. So that would be a great reason to have a Boolean variable. So I'm going to add in a new variable to the variable section of the blueprint. And we will call it isOpen. We'll also make this instance editable so that if you drop the door into the world, you might decide you have it open by default and you'd be able to set this value for each particular instance of the blueprint. By default, because in the viewport here you can see that the door is closed, we'll leave the default as isOpen. So just make sure that the value here reflects the actual state of the door. And we could write for the tooltip whether or not the door is open. Before we actually do anything to the door, we need to know whether it's open or not. So I'm going to drag in this Boolean variable to the event graph here and do get isOpen. So we're getting whether or not the door is open. And what we'll do with this variable is that depending on whether it's open or not, we'll either add or subtract 90 degrees from the rotation on the door component. So for this door, when it's in the open state, we're going to want it to be, let's say, 90 degrees. So Z value of 90 degrees, and then the player should be able to walk through it. When it's closed, we want it to be 0 degrees. You could make this an animation, and eventually there's a good chance you'd probably want to. But let's keep things simple. So what we're going to have happen is that when the door is open, the rotation is set to 90 degrees, and when it's closed, the rotation is set to 0 degrees. It would be possible to do this with the animation, having it actually swing open over a couple frames. That adds another layer of complexity for right now, so we're just going to do it by set values. So let's go to the event graph again, and we're going to need to get reference to this door to check its rotation. So let's go here for the door. So getting a reference to the door by dragging it into the event graph here. And we want to set the rotation relative to its parent. And the reason we're doing set relative rotation is that we're not interested in how the entire blueprint is rotated with respect to the game world right now. We're interested in basically how this door is going to look compared to the rest of the blueprint, like the door frame. So it's either going to be set to a new rotation of 0 degrees on the Z for the static mesh, or it's going to be set to 90 degrees. And so let's copy this component too. So we have one for the closed rotation up here, and then one for the open rotation over here. So this will be 90 degrees. And if we want it to be easier to edit this value, the new rotation for the open rotation, let's actually promote that to a variable here. And so with this variable, we'll call it open door rotation and compile it. You can see that the value has been brought out for 90 by default. Having this variable would mean that it's very easy to actually set the exact angle that the Z rotation should be at for a particular door component. We can also make this instance editable. So that would mean that if you drag a copy of this blueprint out to the game world, you could set it there. So maybe you want the door to open 100 degrees or 80 degrees rather than 90 degrees. So that's why we do that. So now let's split this isOpen Boolean. So I'm going to drag out the pin here, place a new node, and search for branch. So the branch is basically, is it open? If it's open, then we want to close it. So true is open goes to here. And then false, if it's closed, we want it to go to open. And of course, we need to connect the event execution pin to that branch path so that this code can actually execute. And I think the final thing we need to do here is that once we do change the state of the door, we need to set is open. So let's drag in is open onto the graph from the variables and choose set is open from the drop down menu. We connect this value here. And at this point, it should be closed because we set the new rotation to 0 for the Z. And then we can hit Control C and V to copy that node down here where we can have it also set, but then we check the Boolean for is open. So in this case, we are making the door open, and in this case, we are making the door closed. So what we can do here is select these 3 nodes down here, right-click and do Create Comment Group from Selection, and we can say Make Open. And the reason we do that is just so that if we ever look at this code again, it is easier to read and understand. So let's take these 3 nodes on top and do the same thing. So Make Closed. Pretty easy and straightforward. So now that that's done, go ahead, try to compile it. You can see that we're missing a target on the bottom node. So I'm going to copy this get door up here, paste it down here in this make open comment section, and connect the target to the door. So now if we compile this blueprint and save once again, it should compile successfully. Okay, so theoretically now, if any object was to interact with this door successfully, it would trigger the door to open to 90 degrees, and on the second interaction, it would trigger it to close down to 0 degrees. And, just for consistency, we can actually promote this close value to a variable as well. So we can say here, instance editable and closed door rotation. So having these variables just makes it a lot easier to ever change these values, either for the blueprint class or any instances, than having to go in here and manually change the value in the blueprint code itself. So now we can drag the blueprint door into the game scene. I guess we'll just put it up here at the top of the staircase. If we hit play, though, we won't be able to actually interact with the blueprint, even though you can see it has the interaction zone. It does inherit from the interactable class. And that's because the player has no way to actually interact with the blueprint. So if I hit play here and run up to the door, nothing's going to happen. Well, it shouldn't be able to actually run through the door right there, so we might need to change that. So the next thing that we're going to want to do is to add the functionality to the character where it is able to press a button and interact with interactable objects around the scene. So To do this, we can create a child blueprint of the base main character class, and then add some extra code to it. And the reason we make a child is so that basically we don't mess with any of the original content, we only build on top of it. And that's generally a good idea when you're working with someone else's libraries and you want to add new stuff. So with third-person blueprint, we can go into the blueprints folder here, and there's third-person character and third-person game mode. So I want to create a child blueprint for both of these, one to set a new game mode for this particular game, which includes settings like setting what the default character pawn should be, this guy here, to a new one, and then creating a child blueprint for the character pawn so that we can write the interact code on top of the third-person character. So I'm going to right-click and do Create Child Blueprint class, and I will call this Tutorial Character. And I will do the same thing for the game mode, so Tutorial Game Mode. And now we can double-click on this game mode, the Tutorial Game Mode that is, and we can change the default pawn class. So we're going to want to change that to Tutorial Character, the one that has a guy there, I believe, and compile that. So the only thing we need to do left with that for now is to go up to Edit and then Project Settings and to change the default game mode. So if we search game mode here, we can change the default game mode to one that we have set up. So let's change this from third person game mode to tutorial game mode. Yeah. So now if we exit out of all that, the third person character should actually default to a tutorial character. I don't know if that will replace the one in the scene. So let's go ahead and take a look here. Tutorial character. Nope. Okay. So the character here still needs to be replaced with a different character. Okay, so the way that we can swap out this character successfully and have the player controller latch onto this player character here is to delete the third-person character. So I'm going to Control exit from the scene to cut it away. I'm going to drag in this tutorial character, and we need to search for a setting called Auto Possess. So Auto Possess Player, we need to change that to Player 0, which by default is the single player, the player at your computer screen. So once we do that, this tutorial character should be able to grab the player controller the same way that the third-person controller did. Aside from having different class names, they're essentially exactly the same thing as things are right now. The character still can't go through the door, and it can't interact because there's no interact button set up. Okay, so what I would recommend you do at this point, rather than hard coding your input, you can actually go up to Edit and do Project Settings. And from here, you can set what you'd like an input key to be for interacting. So action mappings here, you can see that you can add one. So I'm going to add a new action mapping, and we will call this the interact key. And we can default this to a key value, such as F on the keyboard. E might work as well. So search for keyboard F, put that in there, and save the project settings. So the advantage of doing this is that now when we write code, rather than saying that when F key is pressed, we say that when the interact action mapping is pressed down, then we can trigger the interact. And that's handy because now anytime we want to change the setting across the entire game, we just come up here to the bindings for the game, rather than hard coding a key such as F. So let's have that set there, and now we can go into the tutorial character blueprint and finally write the interact code. So double click on tutorial character, and I think we're just going to go straight into the event graph for right now. And we're going to want to have this character react to the interact keys. So if we right click and we just type in interact, we should get the action event to pop up here. And we can just select that as a starting node. So when the interact action is pressed down, we want to try to interact with the nearest object that can be interacted with. So we're going to want to get a list of overlapping actors. So let's right click and type in get overlapping actors. So this is a collision thing. So basically, some component on your character needs to collide with a component on the interaction area in order for this to work. Okay, so when interact is pressed down, we want to get the overlapping actors. And then for each of those, we want to check to see if it implements the interactable interface. If it does, we interact with that object. And most likely, we only want to interact with one object at a time. So after we find an interactable object, we just break from the loop and ignore all the other overlapping actors. So let's drag this array down here and do for each with break, and we'll connect the loop here. So for the element that is overlapping, we want to cast it to the interface. So cast to... Okay, so with interfaces, you don't actually cast to them. You find out if any of the components actually implement the interface. So what we can do here is type in interface here, and I think the thing we're going to want to do is get components by interface. So we'll get the components that implement the interface. Theoretically, there should only be one on the object, but I guess we'll have it call on all of the components that actually do implement the interface. Return value, another for each loop. And you know what, let's put another thing in between here. We'll see does implement interface. So does the object implement the interface at all? And then that'll allow us to set a branch path. So we don't actually need to get all of the components here. Okay, so the idea here is going to be that only if it's true do we bother to go into this loop and get all the components. So make the interface BPI interactable in both cases. And so if it reaches this for each loop, then we're going to want to call the interact method on all of those interfaces. So for the element that we find that has the interactable interface, put in interact. So we're going to trigger the function that's in that interactable implementation. And so once we're done going through all of the components that have that interface for that object, we're going to complete this and we're going to make that the break. So the idea here is that once we find an object that meets these conditions and actually does an interaction, then we're just going to break over here. And that means that any other overlapping actors don't get a chance to be interacted with. So I'll create a comment here, interact with all components on actor that implement interactable. And I guess the rest is pretty self-explanatory, so we could just leave that at that for now. I'll get rid of those other event pins for now. So go ahead and compile it, and it might work now. I'm not sure if we're going to need like another collider or something to put into this overlapping actors thing. So the character actually has its own collider here, the capsule collider, so we might already have everything we need set up. So let's go ahead and test it. So the interact key is F, right? So if we go over here and we press F, nothing happens. Okay, cool. So let's debug this a little bit. Let's start by making sure that the interact action is actually being pressed and is being consumed by this tutorial character. So I'll right click and do toggle breakpoint, and now we can hit play. So when we go to the game view and we hit F, we can see that it does trigger that breakpoint. So let's hit F10 to continue now. And overlapping actors is probably nothing, right? Yeah, okay. Okay, so I think what we might be able to do here is get rid of this overlapping actors thing. And instead drag in the capsule component, and we will check for collisions on that. So get overlapping actors or components. Okay, so I guess we want actors here. And let's try doing that specifically. So this time, instead of checking on the character, it's going to check on the capsule component specifically. Let's give that a shot. So let's hit play and go up to it and hit F. So I'll set another debug toggle breakpoint over here after the branch. So this should only trigger if it finds some overlapping actors. Now let's go ahead and hit play. So I'll hit play. We go up to the door, hit F. And it looks like we've got at least one or two. So it looks like it is overlapping with the door. So finally, that's good. And we just need to see what's happening here. So F10 to continue. So this array should just have that one component. Okay, so here's the problem. There's not components that implement the interface here on this door object. It's the door object itself that implements the interface. So it's going to not actually reach the interaction there. Yeah, okay. So what we need to do here is not get components by interface, but we just need to call it on the object itself. So let's see, the array element here. Let's see, can we call interact directly? Oh, okay, we can. So we don't need the for each loop. We just need this to occur. So if the object implements the interface, call it on the object and break out from the loop. And then, yep, that should be it. Okay, sorry about that, guys. So let's go ahead and compile here and see if interaction is actually reached. So let's hit play and go up to the door. And okay, that debug hit, this debug hit. So let's remove the breakpoint, and we have the interaction. So let's see. Is the door open? Currently it's set to false, so it opens it up. And yeah, let's resume. What happens? Okay, it doesn't look like it actually changed. Okay, so you can see here, the problem is that the door itself actually needs to be movable. So in the door blueprint, we take the door and we set it movable. Note that the door frame and that the door root don't need to be movable. It's only this door part that's going to change. So let's compile that and run it one more time. And hopefully it should work here. So it triggers the event. I'll just remove the blueprints and let's resume game. Okay, looks like it's working nicely. So F. Okay, open, close, open, close, open, close. Okay, sweet. And on top of that, we can walk through the door properly, but when it's closed, we can't walk through the door. So that's pretty much exactly what we want. Let's see. It's a little hard to open the door from the other side, but it does work. So we might want to expand the zone at which we can do that. Let's just go ahead and take care of that interaction area and expand it a little bit. So hitting R on the keyboard in order to trigger the scale mode, and just stretching that area out a little bit for usability's sake, so we can go up to the door and hit F, open it, go through it, turn around, hit F, close it again. And that's pretty much all we need to do for this. So this is how you would set up a interactable object such as a door within the game. And if you implement it as an interface, then you'll only need to write the interact code on the player object once, and then you can describe in each of the interactable objects how that interaction should be, whether it's opening a chest, opening a door, adding an item to your inventory, whatever. All the game needs to know is that it is dealing with the interactable object, and you can define how it should interact with the object on each individual object. So that's pretty much the gist of how you can add a door to your game. You could make this a little bit more fluent with an animation here rather than just immediately setting the value. But hopefully this gives you a good idea of how to implement doors within your game and how to implement interactable objects in general. So I've been Chris, thanks for watching, and I will see you guys in my future Unreal 4 content.